Okay, anyone have an answer to this puzzle? Yes, Clay?
Well, I don't know if it's an answer, but assuming more single people would probably prefer something speedier because they're not, and a family would consider space much more of a preference, seeing as they want something maybe safer, more room for the kids, that sort of thing.
Yeah, we could have said safety rather than speed as another attribute.
And so I think that the indifference line might be something, well, I guess for single people, it'd be geared towards more speed rather than space.
Right, okay.
And the inverse for families.
But so we want to think about that as the trade-off between these two attributes. So their willingness to trade a certain amount of one to get a bit more of the other. So let's let's do it this way. So suppose we have two sets of indifference curves, and one of them looks like that, and the other one looks like this. Can you associate these two sets of indifference curves with different demographic groups? Eric?
The bottom set is likely going to be the younger demographic, and the top set the older demographic, because the bottom set will give up more space for an increase in speed, while the top will give up speed for an increase in space or safety.
So you think these are the youngsters and these are the...
If we're assuming that young people and not old people want fast colors.
Right. Yeah, it's kind of a stereotype, but...
We don't say
Right.
old people.
Okay. Any other opinions? Excuse, you concur, you second that? Councilman, all in favor? So we can think about this in terms of the marginal rate of substitution. So how is the marginal rate of substitution for these members of these two different demographic groups likely to compare? Well, for the people at the bottom here, so in order to get an additional unit of speed, these people are willing to give up a lot of space, right? This is what Eric said. Well, these people up here to get that same, let's see, we just do it exactly the same way. Carry this up here. For these people to get that same additional unit of speed, they're willing to give up very little space. So these are we have the family
folks.
These are the family folks. And these would be the singles. So when thinking about consumption behavior, we can associate with demographic characteristics, and actually it can readily be observed that people's preferences change after they have children. Now you might say, well, okay, so this is all very interesting, of course, but why are we doing this? Why aren't we just taking a simpler route to thinking about preferences by saying something like, well, people are going to choose what makes them happiest, and we can associate a certain level of happiness with each indifference curve. So if we have, let me draw an indifference map again. Bunch of indifference curves. Well, what we said is the baskets on the one farthest out to the right here are going to be preferred to the next, which is preferred to the next, which is preferred to the next set of baskets. Well, why don't we just say, okay, so that basket makes people happier, and we wouldn't need to make all these assumptions. there's a possibility of doing that. We could associate a particular number, call it U for utility associated with each of those indifference curves. And if it's true that the baskets on that farthest out indifference curve are preferred to the other ones, then it must be the case, or we could say this is how we're going to measure things. U4 has to be a number which is bigger than U3, which is bigger than U2, which is bigger than U1. So utility is higher on an indifference curve which is farther out than is closer in. And in fact, this is useful for further developing our intuition about the convexity, because on the if we write utility as a function of the level of consumption of the two goods of let's see, I should be writing F and C in that order. It doesn't really matter again, but just for consistency, F is on the horizontal axis. If we write utility as a function of food and clothing, well, then it is going to be the case that the change in utility is going to be equal to, so when we're comparing two baskets, the change in utility moving from one basket to another is going to be equal to the difference in food moving from one basket to another times the additional utility that one gets from that food. So this is a derivative also. It's written with a small Greek letter. Basically, it's the same as the D, but it's taking into account the fact that we have multiple variables here. So you can think of this again just as a slope, an additional utility coming from extra food. It's going to be this plus the change in clothing times the extra utility that you get from having additional clothing. Okay, and in moving between two baskets on an indifference curve, what will the change in the utility be? It may seem like a trick question, so let me say, suppose this is point X and this is point Y on the same indifference curve. The change in utility moving from one to the other is, I'm looking for a precise number here, like minus 306. Moving from X to Y, what is the change in utility? 0, right? It's not changing because you're staying on the same indifference curve. So on an indifference curve, we have change in utility is equal to 0. So that implies that 0 is equal to all of that, and also that we can write then delta C delta F is going to be equal to minus this extra utility from an additional unit of food divided by the extra utility from an additional unit of clothing. Okay, so this is just a little bit of algebra to get to this equation. Now, let's think about the intuition for that extra utility you get from an additional unit of food or clothing. We call those the marginal utilities. This is a very important moment in this class because We're using the word marginal for the first time. Marginal is one of the most important words in economics. So this means the marginal utility of clothing. This correspondingly, this derivative here is the marginal utility of food. And so what this is saying is that the slope of the indifference curve is equal to the negative of the ratio of the marginal utilities. Okay, or if we think of it in terms of the marginal rate of substitution, the MRS equals that marginal utility of food over the marginal utility of clothing. Okay, now I promised you that we're doing this for a reason, and the reason is to try to understand convexity better. So let's come back here to our graph of where we were discussing convexity in terms of the MRS. And now let's rethink it in terms of the ratio of marginal utilities. So the basic idea here is that marginal utility declines in the amount that you have something. So if you only have a little bit of food, then your marginal utility of getting some more food is high. You know, you're starving, and so getting a loaf of bread, you know, brings you a lot of additional utility. Well, if you have plenty of food, getting a little more food doesn't bring you that much more utility. It's still positive because you're not satiated, but it brings you less additional utility. And the same is true for clothing. If you have only one set of clothes, then you know having another set is brings you a lot of additional utility. While if you have 100 sets of clothing, one additional set more. You still want to have it because you're not satiated by assumption, but it doesn't bring you that much more additional utility. So then if we come back to where we were at this point here, so somebody tell me about marginal utility of clothing and food at this point relative to, say, a point down here. The marginal utility of clothing is high? Who said high? David, right? Who else thinks it's high? Marginal utility of clothing is high here. Here you have a lot of clothing. Levi?
I think it's low.
You think it's low? Anyone else?
Yeah, it's low.
Cannot be determined with information given. Hayden?
It's low.
Low. Yeah, so if you have a lot of something, then the value of an additional unit to you is low. So marginal utility of clothing is low here. What about, you don't have much food at this point, so what about the marginal utility of food? Marginal utility of food would be high. So this ratio, this MRS, high marginal utility of food, low marginal utility of clothing, so this is going to be relatively high, right? And the MRS here is going to be relatively high compared with a point farther down the indifference curve where, say, you have very little clothing, meaning your marginal utility of clothing then would be high, but a lot of food and your marginal utility of food then is low. So that just is another way of saying you have a diminishing marginal rate of substitution. Because you can think of that marginal rate of substitution as the ratio of these marginal utilities, which are changing as you move down the indifference curve. Now, we can distinguish, when we talk about utility, we can distinguish between two ways of thinking about utility. So we have have an ordinal way, where it's just about the order. So basically, that's what we have here. So utility is just, these are just some numbers. It doesn't matter what they are, as long as they preserve this order. You know, it doesn't matter if this is 100, and this is 10, and this is 3, and this is 1, or if there are 4, 3, 2, 1, right? Because U4 is still larger than U3, etc. So that's the ordinal view of utility. The other idea is that utility is cardinal. So that means it's measurable. So it's possible to make statements like, if we have, say, another basket here, Z, so the, let's have X, Y, and Z. So you might make a statement like, I prefer Y to X twice as much as I prefer X to Z. We don't generally make statements like that, but actually walking to school this morning with my 9-year-old daughter, she said, Nico, her friend, who is the son of another faculty member here, he likes ice, because she was stamping on the ice on the way to school. He likes ice twice as much as she does. I thought, wow, that's cardinal utility. I tried to explain it to her, but so generally, we don't feel too comfortable making statements like that. You know, we can say, yes, this basket, I prefer this basket to this one, but how much more do I like it? Well, I don't know. It doesn't seem so meaningful. Nonetheless, cardinal is useful in some contexts, and sometimes even just now, I kind of made cardinal arguments. Really, our argument should be, in an ordinal sense, they can just be about this ratio. The ratio can be ordinal. And where we talk about each of these separately, then it is cardinal. And cardinal utility actually has a long history in philosophy, going back to Jeremy Bentham. Anybody heard of Jeremy Bentham? He was an 18th century English philosopher. And actually, you can go visit him. You know about that? He's still available for visiting. So I was at a conference at University College London, and we went, so just outside the main hall, you go into this room, and there he is embalmed. You can visit him there. They say it's not the real head anymore. There used to be like some rivalry between the colleges and the University of London, and they would like stole the head, and I don't know. So anyway, he thought that utility was measurable, and eventually we would figure out the way to have the best possible society by measuring people's utility and maximizing it. Not too many people think that anymore, except maybe with brain science, maybe we start to make some progress in measuring happiness. I don't know. I'm a little skeptical. But he invented the notion of utility, and Hayden, have you visited Jeremy?
No, it was actually a question. Is the MRS, the two equations you have right there, are those equivalent then?
Yes. So this is the negative of the slope. So we showed that here, right? That's the same. The delta is the same as the d, right? And when we defined that negative of the slope as the marginal rate of substitution. So therefore, the marginal rate of substitution has to equal the ratio of the marginal utilities. So we proved that. And again, the reason for proving it wasn't just, because we like to prove things, we enjoy calculus, but the main reason is to help us better understand the convexity of indifference curves, because that's going to be really important when it comes to deriving demand. Quincy?
Does it matter which
The horizontal or vertical axis?
Yeah.
No, everything will flip over if we did it like that, but it wouldn't matter. We just need to keep straight in our own minds which is which. But no, these are arbitrary labels. Say F stands for clothing and C stands for food. It doesn't really matter. They're just symbols. They can be X and Y. They can be other goods, apples and bananas. We'll look at other things than food and clothing, but no, it doesn't matter how they're. So if they were switched, so this was F and this was C, then this would be MUC over MUF. Okay, well good, so that's it for preferences. We're done with preferences. Now we need to talk about constraints. Budget constraints. Actually, budget constraints are a lot easier than our preferences. We're going to assume that this consumer, I mean, I call this, I say assume, but this is not an assumption like those assumptions on preferences. This is more just kind of a definition of the problem. And the problem we're looking at, this consumer has a fixed budget. We're going to call it income. I for income. Income is fixed. It's a constraint. In the problem we're looking at, the consumer has no influence over his or her income. Of course, in labor economics, one of the main questions is how people affect their income by working. They make choices about how much to work, where to work. Those choices are also constrained. The factors that lead their earnings to be higher when they work, things like education, those are also come into play. But here, we're going to take a simple problem where income is fixed. And this is a consumer also who doesn't have a very interesting life in a certain way. This life is just like, it's one period and then it's over. This income is spent during that period, and so there's no savings, nothing like that going on. And there are only two things that this consumer can spend his or her income on. Guess what they are?
Food and clothing.
Food and clothing. Yeah, just keep things simple. Yeah, good guess there. Okay, so if that is true under all those assumptions, it is going to be the case they're going to spend all of their income, remembering the non-satiation, so they're not going to like leave any income unspent, right? So they're going to spend all of their income on either food, for which they pay a price of PF per unit of food that they buy, or they're going to spend on clothing at price PC. Okay, so that is their budget constraint. Anybody itching to draw a graph? We haven't had a graph in at least 5 minutes. So we can graph this.
Okay.
We're going to graph it in the same space, FC space, as before. So what would the graph of that function look like? We can kind of reason a little bit intuitively looking at this, or we can derive the equation that then will just show us what the graph looks like right away. What do you want to do? What? Which?
A downward slope line.
It's going to be downward sloping line. Yeah, how do you know that?
I started.
You've already done the homework.
No, I started it.
You started the homework, okay. Well, yes, but that doesn't really answer the question, but it says how you learned the answer. But so what's the argument for why?
Trial and error. Trial and error.
Trial and error. Well, this consumer has to know what his or her constraint looks like. Clay?
I guess it's similar to the indifference curve, as in, if they're only spending their income on two fixed variables, meaning that it's going to be some trade-off of one variable for the other.
Right.
And so the more you spend on food, the less you spend on clothing. The more you spend on clothing, the less you spend on food.
Okay, so that's excellent intuition for why it's downward sloping. Marlon, were you gonna say?
Yeah, the second part of that was essentially what I wanted to get at.
Okay, good. So, can we pin it down a bit more? So like, if it's downward sloping and it's a line, anybody know what the slope is? Well, do you know, if it's a line, so does it intersect the vertical and horizontal axes, and if so, where?
No.
It doesn't intersect them? Oh. Well, if it's a line, if the slope is constant, then it must.
Does it intersect that person's income?
Intersect which?
At their income?
Well, no, so on this graph, we have F and C. Chris?
Yep. So it intersects the x-axis where clothing is 0.
Good.
The y-axis where food is 0. But there's no.
Yeah, that's the definition, but tell me, so what is the value of this point on the f-axis?
Income over.
Income over PF. Okay, so how'd you know that, Levi? And you can't say because you did the homework.
Because if you have a fixed amount of income, you divide it by the cost of whatever
Yeah.
you end up of food, you end up with the amount of food.
Right, because here you're not spending on clothing, right? Only on food, like Chris said. But then, you divide your income by the price of food and you get how much food you can spend, right? So that has to be a point on the budget constraint. And analogously, on the vertical axis,
Income
so the
over,
vertical intercept has to be I
over the price of clothing.
over PC, exactly. Okay, and if it's a line, then it's going to be the straight segment which connects those 2 points. And now actually, even from this, you can tell what the slope is. 1? No, in general, it's not 1. Right, so it's going to be the vertical axis over the horizontal axis with a minus sign in front of it. And so if we, because it's a ratio over a ratio, then if we flip those over, we're gonna get minus PF over PC. Okay, so that's an intuitive way to see how to graph the budget constraint. Now, what you would have learned, way back when, quite a few years ago in school, about how to derive this equation, you would learn we want to solve for the variable on the vertical axis, which is C. So if we solve this equation for C, what are we going to get? We're going to get C equals, okay, you check my math here, I over PC minus PF over PC times F. Is that right? Okay, if that was hard for you, then remember the 15 times spot we did last time. So if it's hard, do it 15 times. Okay, then it'll be easy. So but this is a form of an equation that you've been seeing, some of you for 20 years, some of you for only 10 years, but at least for that long. So this is an equation, imagine you have y equals, something like a plus bx. With this equation, a is a vertical intercept, right? Because y is equal to a when x is equal to 0. So the vertical intercept, I over PC, hey, check, you got that one. okay? And the slope, B, here is minus PF over PC. So this is just a normal linear equation. No great magic there. We can derive it from writing this, the budget constraint this way. These are equivalent statements. Okay, so preferences are really interesting, of course. You know, we had a great time talking about them. But budget constraints from a policy point of view are even more interesting because generally policies are not designed to affect people's preferences, but they're designed to affect budget constraints. What kinds of policies can affect the budget constraint?
Tax cuts.
Tax cuts, like what sort of tax cut? Income tax cut.
Yes.
Okay, so an income tax cut. How would an income tax cut be represented here? We're still talking about one consumer, right? So this consumer gets an income tax cut, so therefore his or her income that was, you know, fixed for the purpose of the problem, but we can see nonetheless what happens then if this person gets a higher income. When we think about the consumer's problem, we should always be thinking in post-tax terms, right? Because what matters is the money you have to spend after paying taxes. So this should be post-tax, so that would mean post-tax cut, your income is higher. How would that be reflected on the graph?
Shift to the right.
Yeah, so an outward shift of the budget constraint. So that would mean both intercepts would move out? Yeah, because I is moving out in both cases. What about the slope? Would the slope change? No, because prices aren't changing, right? All that's changing is income. So that means there's a parallel shift. Is that the parallel budget constraint, I mean, the definition of parallel is same slope. Okay, so we would have that kind of outward shift. Tell me about another policy.
SNAP benefits.
Which?
SNAP benefits.
Okay, so that's a complicated one that, let's talk about it. Good. SNAP benefits. Okay, so SNAP benefits means, so what are food stamps? They're basically a voucher. What's a voucher? A voucher is a kind of limited money. It's limited in the sense it can only be used for certain purposes, right? So nowadays, food stamps are actually like a debit card, and they contain, you know, there's money on there, but when the person uses it in buying food, in buying something, it has to be food items, otherwise, you know, it's not accepted for buying it. So how would we analyze that? Okay, suppose this is our original budget constraint. Before getting the SNAP benefits, and now there's SNAP benefits. Parker?
Well, it wouldn't shift C, but it would shift F to the right and change the slope.
Would it change the slope?
No, I guess.
It wouldn't change the slope. So that's interesting because price of food doesn't change, right? I mean, at least we're thinking for one consumer, right? It may be if lots of people start consuming more food, the price of food could change. But let's think of for one consumer, just to keep it simple here. So no change in price of food, no change in the price of clothing. So then what would the new budget constraint look like? Levi?
It looks like the same line shifted right, although it doesn't intersect F at 0. There's a horizontal line that extends from where it intercepts C to wherever the value of the rebate or the voucher is.
Okay, very good. Yeah, so we can actually That's exactly right, but, so let's think about this intercept, and so suppose you have somebody, you know, just to see how this works, let's suppose there's somebody who's not consuming any food, okay, they're at this point here, they're consuming only clothing, and they get the food stamps. Well, what they can do is, they can consume, say this is the amount of the food stamps, now they have this point available to them, right? So they're spending all of their income on food, on clothing, and using the food stamps to buy food. Okay, so that's one point. This is a point on the new budget constraint. And then the rest of the budget constraint
is as it was. It has the same slope intercepting a new F intercept.
Right, so it'll be a new F intercept. So the new budget constraint will be a parallel shift out, but it won't go above the same level here. Why not? Why couldn't it be up here?
Because you have no extra money to spend on clothing.
Right. So it wouldn't be the same as an income change. And an interesting question is, well, so we have this food SNAP program, which is providing vouchers. Well, why not have a cash program, or what's the difference what difference does it make in people's behavior, in their food consumption, and ultimately we'd like to ask also in their utility. Okay, so that's not a question that we're ready to ask yet, but there's the answer to David's request that we look at the SNAP budget constraint. What other kind of policy? So we had taxes involving income, but we can also have taxes or subsidies involving food and clothing, right? So a tax is going to raise the price to the consumer, and a subsidy is going to lower the price to the consumer. So we can analyze what happens to the budget constraint when there's, should we do a change in the price of food? So this is our original budget constraint. And price of food, what do you want to do? Go up or down?
Up.
Up?
Because it usually goes up.
Because it usually goes up. Okay, so if the price of food goes up, then what is the new budget constraint, Eric?
You'll maintain the y-intercept, but it'll have a steeper curve to a horizontal intercept that is closer. It will be shifted to the left.
Right, so there's gonna be a steeper budget constraint coming from the same vertical intercept, right? So the slope, so we had an original slope here, minus PF, say PF1 over PC, and now we have green one minus PF2 over PC, where PF2 is greater than PF1. And because the slope is negative, so a larger numerator implies it's steeper, it's more negative, right? So lots of policies are affecting prices, they're affecting relative prices, so this price ratio, and they are affecting incomes. So many many things that we want to analyze in terms of policies are relevant here. Yes, Tim?
Do we have any meaning of the triangle, the line, what is the line?
Do we have what, a triangle?
The meaning of triangle?
The meaning of this triangle?
Yeah.
No, so
It's only the budget line.
No, so, okay, if it has, so not really, like the area of the triangle or something like that, except what you can think of is that triangle, which is underneath a budget constraint, you can think of that as the feasible set. So it's possible in principle for the consumer to choose anything within that triangle. And so when the triangle gets bigger, like it does here with more income, then you have a bigger feasible set, right? Or here, the triangle shrinks, you have a smaller feasible set. With consumers who are not satiated, they're always going to be on the boundary, this side of the triangle. So no, it doesn't have any special meaning beyond that. Okay, well, I want to do one final thing, which is what, you know, I'm sure you're all like waiting for, right? So, because we have this graph, and we have this graph. Should put them together. Okay, so let's do that, since obviously, you know, wanting that, insisting on it. I'll stay a little bit longer so we can do that. Okay, so we would like to ask the question then. This is the third step. We've done the preferences, we've done constraints. Now, what choice does the consumer make? And so let's say we have a consumer who has an indifference map looking like this. And of course, this consumer has a budget constraint. And this consumer would like to maximize utility, make him or herself as well off as possible, maximize his or her preferences, all those are equivalent ways to say it, given this budget constraint. So what basket will the consumer choose? Eric.
The basket at the point at which the budget line intersects that third
This one here?
yeah,
So the consumer will want to be on the highest possible indifference curve. And so it's going to be this point of intersection, but that's not an ordinary point of intersection. That point is a special kind of point. It is it's a tangency. Who said that? Chris said that. Yeah, it's a tangency. What's a tangency?
Slope at a point,
Slope.
at a point along the curve.
Well, that notion of tangency means it's like you take a line and put it next to a curve, right? So we have a curve, and then we have a line, and they're tangent. Well, so the thing is, so in a tangency, the slopes of those two things are the same, right? So the slope of the budget constraint and the indifference curve are the same. But wait a moment, we know what's the slope of the budget constraint, and we know what's the slope of the indifference curve. What are they?
The marginal utilities.
So the slope of the indifference curve is the MRS, which is the ratio of the marginal utilities. And that slope has to equal the slope of the budget constraint. Right? These are actually the negative of the slope of the indifference curve, right? They're both negatively sloped. So what's the slope of the budget constraint? PF over PC, yeah. It's a negative, but let's take away the negatives from both of them because this is the negative of the, so this is minus slope of the IC, right? And this equals minus the slope of the BC, the budget constraint. Okay, so look at that. Nice expression there. This is, I would say this is easily a top 10, you call it top 5 equation in all of economics. We just learned here in your second week. Okay, so this is the equation that's like, you know, you see in economics lots and lots of equations. Most of them are some version of this. What do we have? We have the ratio of the marginal utilities equals the ratio of prices. So relative marginal utilities equals relative prices. You can think of the marginal utilities as marginal benefits. So what's the relative benefit you get for consuming some more food versus consuming some more clothing? That has to equal the relative marginal costs, because the price of something is the marginal cost. You want another unit of food, you have to pay PF, another unit of clothing, you have to pay PC. And so we have the relative marginal benefits equals the relative marginal cost. If this is not true, then you're not maximizing utility. Let's look at this equation another way. Now, to do it this way, we have to think in more cardinal terms, but maybe it is worth it. So we have MUF. Now I'm going to take PF down here, and I'm going to move MUC up on the other side, divided by PC. Look at this version of the equation. What this means is you spend $1 on food, and that, because PF is the price of food, so that tells you how much more food you get from spending $1 on food. And then this tells you how much additional marginal utility you get from spending $1 on food. This, correspondingly, is the marginal utility you get from spending $1 on clothing. If you're maximizing utility, these two things have to be equal to each other. This is like a bang for the buck, you know? You want to equalize the additional gain you get from spending on everything that you spend money on. Levi?
Can you think of marginal utility as opportunity cost?
No, not exactly.
Not exactly.
So marginal utility is the extra satisfaction, the extra utility that you get from consuming another unit of the good. And so expressed this way, it's the extra utility you get from spending another $1 on that good.
I guess the way I'm thinking about it is at the cost of another unit of food instead. So if you're choosing for more utility through clothing, your opportunity lost for food is the marginal utility for clothing.
Okay, well that's okay. So that's right. Yes. Okay, then I agree with that interpretation. Okay, so I'd like to ask you a question to think about for next week's class. In fact, there are 2 questions I want you to think about. So one is, so suppose this is not true. Like suppose rather than, suppose instead you have the MRS is greater than the relative prices. What should you do? Can you graph it? Okay, and the other question is, what if income goes up? And what if the price of food goes up? So how does your choice change? Okay, these are the questions here. So the first question is important for understanding the solution to the consumer's problem. And it's a great practical use as well, I will argue. And the second thing is gonna be important for understanding the impact of policies on consumers' decisions.